In this video, I'll take a look at rigid bodies, exploring a vital component of our physics system. Right now these objects are static. They have no animation on them, and when we hit play, they're just going to sit there. They also are not going to react physically to anything in the scene. There's nothing on them that's defined either their volume for collision or their mass. They're not going to react to gravity at all. What I'm going to do is to add on a rigid body. First, I'll select the clock, and under Add Component here in the inspector, choose Physics and Rigid Body. I'll do the same with the train. Again, selecting the train, and under Add Component, either here in the inspector or on the top menu under Component, choosing Physics and Rigid Body. Now both of these objects have a rigid body component. I'll roll up my Mesh Renderer and Animator so I can pull the rigid body up in the inspector a bit. What we can see here in the rigid body is that we have mass, drag, and angular drag. There's also use gravity, is kinematic, and interpolate and collision detection. Mass, then, is in arbitrary units the heft or weight of an object. How heavy is it? A drag, then, determines how this rigid body reacts to forces in the scene. Checking or unchecking use gravity, then, determines if that object is going to fall regarding gravity. And this is very useful for debris trails, for example. Is kinematic defines if we're going to put additional animation onto it. Interpolate determines how this is going to look at where it's going and where it's been to determine the next motion. And finally, collision detection, which we can use for fast objects, provides different ways of checking for collision with other objects. We've also got constraints, and the constraints on this rigid body allow us to freeze position and rotation on one or more axes. So we can say, for example, that an object simply cannot fall, but it can get spun by being hit. With a rigid body on both of these objects, I'm going to hit play and see what happens. What we can see here is that my rigid body objects fell. As there's no floor under them and no colliders on them, they simply will fall forever. I'm going to take my main camera and move it back a little bit. I'll pull it back on the Z-axis so I can see a little bit clearer. Again, I'll hit play, and there's my train and my clock falling. On each of these, we can increase the mass as we need to make it heavier. I'll put a mass of 12 on the train, press play, and we see them both fall at the same rate. The reason for this is it's actually the same gravity throughout. However, it would take more force on one object to make the train move because that mass is heavier at 12. Turning off use gravity, then, lets one object fall and one object still be a rigid body but simply not fall with gravity. The other part we need here are colliders and something to collide with, or else we'll fall simply endlessly. I'll scroll back and put a plane down under these, choosing Game Object, 3D Object, and Plane. I'll scale this plane out by pressing R, and then clicking and dragging out in the center of the scale gizmo, and pulling it down on the Y-axis. When we press play, we'll see, again, the train sits still because gravity is not applied, and the clock falls straight through. What we're seeing in this is that we need two components, and we have the first one. The rigid body lets that object fall with gravity, have mass and drag, and be affected by forces and torque. The collider, which we'll get into in the next video then, will let this object understand it is colliding physically with other objects or the player.